Welcome to your first lesson in Chapter 10. Chapter 10 is a fun lesson because we're going to deal with sequences and series and different patterns within different numbers. So sometimes they're like puzzles and you just have to figure out what numbers are coming next. Sometimes we're going to be summing them, and there are a few formulas that you'll have to learn through the chapter. But let's start basically first with sequences. A sequence is just an ordered list of numbers, and you have to figure out how they're ordered and what is the pattern. So it's just an ordered list. Each number is called the term. So you have the first term, the second term, the third term, and so forth. You can have a finite list or you can have an infinite list. And you'll be able to tell, because I'll only give you so many numbers, or it just goes ... and you don't know how many are in the list. But each term is a function of its position. So each term in a sequence is a function of the position and the number of term that it is within the function. Let's do this example. If I'd like you to find the next 4 terms in this sequence of 1, 3, 7, and 13, you have to look for, how are they related? I usually look to see the difference between them initially, and then sometimes you can multiply different, factors between them. This, if I notice, I go from 1 to 3, I added 2, I added 4, I add 6, I bet the next one I'm going to add 8. So if we were to write that out, we have 1 plus 0 is 1, and then we had 1 plus 2 gave us 3. 3 plus 4 gave us 7. 7 plus 6 gave us 13. That's the list we have right now, the sequence. So let's get the next 4 terms. That would be 13 plus 8. That would give us 21. Then we would have 21 plus 10. And then, which would be 31. Then we would have 31 plus 12, which would give us 43. And then 43 plus 14, which is 57. So when you're asked to just find the next so many numbers, it'll tell you how many numbers. You just need to list them. 43, 57. Those are the next 4 terms in the sequence. Sometimes I will give you an explicit formula, and I will say, find the next 4 terms, or the next 5 terms, or 3 terms of the following. Excuse me. So all you have to do is calculate each term and plug in the term. That would be the a sub n for that value. See, this was the first term, the second term. So we're going to plug in the first term. We're going to plug in 1 here to get the first term, a sub 1, which would be 1 cubed minus 10. Always minus 10. The next term would be 2 cubed, right? So you see the pattern. This is 3 cubed. This is 4 cubed. Now you can, yes, I know you can do this on the calculator. You can put that in as the function and then go to the table and you can see the numbers. You can also, on many of these, very quickly just crank them out. That would be 1 minus 10, which is negative 9. 8 minus 10, negative 2. 27 minus 10. And 64 minus 10. So when you just list the first 4 terms, you just simply get those values. That would be your answer. Now, sometimes you have a special kind of sequence that's called a recursive sequence. A recursive sequence uses the numbers, uses each number in the next term. So it kind of spins back on itself. It repeats and uses the previous terms. For example, let's look at this one. And I have to tell you what the first term is so that you know to use it for the next one. If the first term is 3 and the explicit formula is right here, we've got that, then I want you to find the sixth term. Now this little creature right here is where you're putting the previous term. Because if A is, so A sub 1 is 3, if I want to find the second term, A sub 2 right here, then I have 2 minus 1. This is the first term. So when you see the n minus 1, the a n minus 1, that is the previous term. So here we're going to have, for the first term is 3, for the second term we're going to have negative 2 times the first term, which is 3. And then that gives us negative 6. Then to get the third term would be negative 2 times 3 minus 1, that would be the second term, which is our negative 6. See, so you have to, if you get the first one wrong, or the second one wrong, then the whole sequence is shot. That's 12. Then this would be negative 2 times 12, which is negative 24, right? Then negative 2 times negative 24. See, this is not hard. It's a little bit tedious, but you just need to make sure you follow the pattern. 48, negative, 96? That is the sixth term. Okay, so it's recursive. Anytime you see the n minus 1, that means that you're using the previous term in the next, to calculate the next term. All right, let's try another different type of sequence here. The most well-known recursive sequence is what's called a Fibonacci sequence. Very, very easy to do, but you see it a lot, not only in nature, science, the pattern is very, very common. And you start this, and very often you start with just the first term, you would think 1, but you can start with the 0 term. The Fibonacci sequence starts with 2 1s, and then the sequence adds the 2 previous terms. So the next term, or the second term here, would just be the 1 plus 1, which would give me 2. To get the third term, I would then take the 1 plus the 2 to get 3. Then I would take, for the fourth term, I would take the 2 plus the 3 and get 5. And let's do one more. The third term plus the fifth, plus 5, would give me 8. So the sequence becomes 1, 1, 2, 3, 5, 8. And remember what I said about the n minus 1 being the previous term? That is one previous term. But the n minus 2 would be 2 previous terms. So that's where we got here. To get the third term, we add the second term plus the first term. We go 2 back. So you go 1 back and then 2 back to get the next value. So the next value, if I wanted the sixth term, it would be 5 plus 8, and would be 13. So you use the Fibonacci sequence pretty frequently, depending upon if you're studying how things are growing. Trees are growing. There's a good example of that in your book, if you'd like to look at that. And you'll see some examples of this in our lesson. All right, you also, when you are talking about sequences, can talk about the fact whether they converge on a single unique number or whether they are what's called divergent. and they have no limit. They tend to go in opposite directions, and they don't converge on one number. And you can tell this by looking at the graph very often. You can also tell this by plotting or just putting in values and looking to see, do the values approach one specific number. I think your book suggests taking the sequence out to about 8 or 10 terms and see if it approaches a value. There are a couple different ways to do this. The more familiar you are with the equations, you will just be able to identify what's happening. Now, we've done this graph before, and if you have 5 over n, and as you let n be, increase, then you can see what's going to happen to this function. If n is 1, obviously you have 5. If n is 2, then you have 2.5. If n is 3, you've got 5/3 or 4, 5. You're getting smaller as n is huge. As n approaches, so we can say as n approaches a huge number, infinity, that value, the term, will approach 0. And it is approaching the unique number of 0, so we say that this one is convergent. But here in this particular sequence, it depending upon, because it's -1 to the n, depending upon if n is odd, then this will always be a -1, and that will always be -3. If n is even, then this will be +1, and then we always have a +3. So you can't approach just one number. You're either going to be at -3 or you're going to be at +3. So as n approaches infinity here, we are going to, it depends on whether it's odd or even. Let's go ahead and write it out. So the function we said would be a +3 if n is even, right? Because then you would have to an even exponent, so it would be -1 to an even exponent, which would be positive. Or a sub n would be a -3 if the n is an odd value, depending upon how many terms you wanted to go out. And since it's going back and forth, bouncing back and forth, 3, -3, 3, -3, then it can't make up its mind. It is diverging, so it is not converging on one number. It is divergent. All right. You know what? I think I'm going to stop, and we will come back in the second video, and we'll talk about a series. So now the series means we're going to take the sequence and we're going to add them up. And so we'll play with that in part 2. See you then.